So that's it for problem set 7. Let me use the remaining time for the same thing with the problem set 8. So let me go into modules and just navigate to problem set 8. So this, I don't really need to unlock any of it. Can ignore this for now. I do need to clear this so that I can access this. So let me clear this. So we have about 30 minutes left. Let me see what I can do. Now, last semester, when I was doing similar stuff with ChatGPT, magnetism is where it really struggled. Because I can imagine, because magnetism is where you do need more geometric stuff, like the entire the magnetic force. It's defined using cross product. It's a geometric thing. So I could imagine why ChatGPT struggled with magnetism topics last year. So I'm interested in seeing, how much better is it now? So let me pretend that I'm working through this problem set. And so we have 30 minutes. That's probably enough for maybe 3 questions, 4 questions. So I'll pick some substantive questions and ask. Now, there's a non-substantive question that I still want to ask. Actually, this is some new mode. Yeah, I might try it at some point, but right now I don't think I need it, because Canvas is for keeping track of your ongoing work, and I'm not quite doing that at the moment. So yeah, one of the things I want you to test is how well it does this. Let's see, is it just question 1? I also have this. So let me do both questions. So this time, yeah, so I'll say it this way. Can I? Yeah. All right, I think that's enough. All right, so I'm struggling with the magnetism intro. I have to use the right hand running this question, and I'd like to like some answer keys to make sure I got it right. So let's see. I do really want to just check if ChatGPT can get correct answers here. It's gotten a lot better, so it probably can. But it is one thing that it was struggling with the last year. So I want to give it a try. So I think it'll understand the 2 images I'm pasting in are from the same question. Let me zoom in the normal way. So direction of force A is in, yeah. So let's work through, or let's have ChatGPT work through, and let's see if the answers are right. Right hand rule, yeah. Positive charge moving in a magnetic field, yeah. So that's the whole hand version, which I like. Whole right hand in the direction of, let's say, velocity is this way, then whole right hand in that direction. Let's say magnetic field is coming out of the screen, then orient my hand until I can bend the fingers that way. Then the V cross B is in this direction, and that should be the direction of force for a positive charge. So A, velocity is down, so V cross out of the screen B, so the force should be to the left. Yeah, I think that's right. Force is to the left. B, V cross B, so the force should be into the screen, I think. Yeah. And I'm consciously using right hand, knowing that as long as I didn't mirror my video, your perspective, my perspective, right hand works. So I said into the screen. So, out of the page. That let's see. No, that's wrong. Yeah, it might still be upward, holding toward the right. So, I mean, if you are following these descriptions, you'll get the correct description, which is into the page. But it's described as out of page. That's going to be wrong. So you might still be struggling with the geometric reasoning, possibly. Let's see. Case C, so V cross, that's into. the page. Yeah, V cross. See, so force should be upward. See, down. I think it gets into and out of page confused. So the trick here is that on the page here, it looks like arrows going into the page. So so that's how you should just apply. You know, V cross B and up. Yeah, and whether I do it from your perspective with the into the screen being from your perspective or from my perspective, you know, V cross B into the page being from my perspective, it should still, yeah, but force direction now. So it's missed the two. Let's keep going. D, yeah, should be 0 because they're just parallel or anti-parallel. I prefer to say anti-parallel to denote that the angle between them is 180 degrees, not 0. So, okay, got that right. This is 0. Direction in, wait, I missed it. This was marked as down. This is 0. And direction in E is, so V is going into the page, B is up, so V cross B, it's force going to the right. Is it gonna, yeah, so I think it basically doesn't get into and out. So it'll miss this. Yeah, so as I was saying, last semester ChatGPT didn't do these questions all that well. And I think that's probably still the case because it's, yeah, and this isn't even, should be 0. I think if we, out of the page, cross B, oh wait, cross B, V cross B, so that should be down. But it said 0. Yeah, that's bad. I think it got what, 2 right? Maybe 3? Well, 2 right. Yeah. So let me give you the correct answers, which is, or let me give you this a try. I wonder if we can correct itself. I only got 2 right. I wonder, yeah, so if we can correct itself, that would be great. If not, I'm gonna give it a little bit of nudge by kind of saying that, okay, corrected, okay. First should be into the page. I mean, it's one or the other, you know, if you got the thing wrong. Should be up, okay. Yeah, I mean, it's weird. Why didn't it get it right the first time? Should be right. Yeah. So, as I said, you know, before, it's oh, but it's still case F. So I'm still gonna miss 1. So I'll do that and then try to get it to correct itself on this. So, so for F, you said velocity is to the right, but I think the green dot represents the velocity coming out of the page. No? It'll probably correct itself and give me the correct direction. F is coming out of the page, so F should be down. Is that right? Coming out of the page. Yeah, down. Yeah, good. So yeah, just give it multiple tries. I think I've described the ChatGPT as a kind of a tutor. It makes mistakes here and there sometimes. Sometimes it doesn't interpret the diagrams correctly, but you as the human being who can see visually that looking at this, it doesn't look like a vector pointed to the right. You give it new information and it's able to work its way to the correct answer. Yeah. So even though you might be struggling more with the geometry, that's probably not a showstopper. You can still work your way through it. So, okay, I got 20 minutes. Let's see. I think I can skip this question. This question is slightly harder in that I wonder if, I am curious how well ChatGPT will do. It's slightly harder in that you are not doing V cross B. You are kind of figuring out, okay, if I do V cross B, what kind of So, or I get this kind of f. What should be the direction of b, so that v cross b gives me this. And I will tell you a trick that you can use, something called the cyclic permutation. But I don't know. These questions at this stage, it's probably better just to being brute force. In this sense, v cross b is equal to f. So you start with the v. Okay, how should I curl this finger so that f is to the left? So v cross b. Okay, b must be into the page. That's one way to do it, and I'll show you one other way after playing with the ChatGPT. So I'll also say I'm confused about this one. Also sleep deprived, although it's about a specific question. You need to find the direction of magnetic field that would result in the given force that way with the charge. Yeah. Reverse the right hand rule. Okay. Reverse the right hand rule. I don't like how it's being described. So rather than telling you reverse the right hand rule, I will show you this. I mean, you're not really reversing anything. If anything, you are permuting. That's really what it is. I won't bother correcting ChatGPT. But so if you have something like this, I'm just going to write them as just the vectors. Let's say you have vectors C that comes from A cross B. And this is let's pretend that these are unit vectors. So you're not dealing with the magnitudes, you're just dealing with their directions. Then this is what's true. Starting out with this, you can do what's called cyclic permutation. By permutation, we mean like moving these letters around. If you swapped them, that would be a form of permutation. Now, if I simply swap them and have a B cross A, this is not a cyclic permutation. Cyclic permutation keeps the order of the letters the same. Like if you go A, B, and then wrap around to C, and in a cyclic permutation, you can still go in the same order. Start with the A, go to the right, find the B, and then if you need to, wrap around and find the C. Here, you start from A, and then you go to the right, okay, wrap around to get to C. Oh, that's not B, so it's not cyclic. So starting with this, I can get two more cyclic permutations. I can get, moving A over 1 and B wrap around, I get B is equal to C cross A. And I can do that one more time, move A up, wrap around, then I get A is equal to move B over, B cross C. This entire group is what we would call cyclic permutation. And the special thing is when these are unit vectors, these equalities, they hold. So, we had this. Force is equal to QV cross B. And let's say we are just interested in their directions. Whatever their magnitudes are, I don't care, we'll just work that out later. But I care about their unit vector directions. Oh, in which case I don't need a Q. It's unit vector. So so you can generate these other relations that are true based on the cyclic permutation. Move everything over by one and wrap around. So I can say B having wrapped around, B is equal to F cross V. And I think actually this is what I need. Right hand side, it has F and V that I have. So I do F cross V, like for the C here, I do F cross V, that gives me B that's coming out of the screen. And that is the rule that ChatGPT is giving you, but it's calling reverse the right hand rule. You do F cross V, the cross product gives you B. Again, I don't really like this reverse the right hand rule because special case, but this property of a cross product, that when you do cyclic permutation, the vector orientations are all right. That's I don't know. I think it's useful to know. I don't know how often you would use it, but it's one of those math trivia that'll sometimes get you out of some difficult questions. So let's just see how well it answered this part, and then we'll move on from that and do some substantive questions. So I'm not really gonna read it in detail. I'm just checking to see if it got the answers right. If it didn't get it right, then we'll point out what would have been the correct answer. I'm just interested in, how good is ChatGPT at doing these geometric exercises. Oh wow, very good. Yeah, got it right. No complaint. Yeah, it's good. All right. So okay, we got 15 minutes. Let's find some questions that are substantive and worth doing. Velocity selector could be good. This can be good. It requires you to use knowledge of a few things, like the velocity selector, and then have how much charge. So yeah, let me do it this way. So let me do this question. I think this question involves enough of the moving parts that I can imagine someone looking at it and just feeling lost. Let me just channel that and ask ChatGPT to help. And I this time kind of forgot to prompt it with my usual prompt, but let me just give it my the usual description along with this question. So I'll ask it the question, and I'll say, I got this question, and I feel pretty lost. What velocity selector? I mean, this is all described in the textbook, by the way, but I'm channeling. Velocity selector. What do electric and magnetic fields have anything to do with it? And how do I get mass of the Li ion from the radius of the arc? I wonder how long of a response it would give. Okay, step by step. Yeah, it's probably kind of recalling that from memory, from me requesting that over and over this semester. Understanding key concept. Velocity selector is a device that uses both electric and magnetic fields to allow only particles with a specific velocity to pass through. How it works. Yeah, when it describes that, I hope you have an image in mind. It should look, this is the image you should have in mind. Imagine a region where you have like electric fields set up this way, going up. This could be set up with two infinite parallel plates, and then you would have magnetic fields to be perpendicular to this. Now, so this charged particle that's moving through, it should move in a way to perpendicular to both the electric and magnetic field. So in I guess traditional drawing, I draw them so that particle path is going this way. In that case, magnetic field can really be only along one axis, either out of the page or into the page. So if this is the electric field, then magnetic field would have to be either into the page or out of the page, something like that. And you could also rotate it around, have magnetic field, let's say. So if you decided on the direction of the magnetic field first, and had the magnetic field just pointed this way to the left, for example, it's still perpendicular to the electric field. Then in order for this arrangement of electric and magnetic fields to act like a velocity selector, the particle path would have to be perpendicular to both of them. So the only way is either going into the going into the screen or coming out of the screen for the velocity of the particle. So that's the mental image you should have in your head. This three-dimensional arrangement, it does take some kind of thinking through to make sure the image that's in your head is correct image. Now, in terms of doing the question, all you need is kind of the formula, which ChatGPT is driving. Charged particle moving through, experience force from both, and I think it's not explicitly saying it, but the particle would be moving so that the direction of electric field doesn't matter quite much, but direction relative to magnetic field matters. For the magnetic force to be exactly this, instead of V cross B, the velocity vector V and magnetic field B should be perpendicular. So, yeah, they must balance each other out. So set up that equation. Then V, it's a kind of amazing thing. You do electric field divided by magnetic field, like looking at these units. V over m Tesla, you might not think, oh, V over m divided by Tesla is meters per second, but yes, it is meters per second. So yeah, this is the description of the velocity selector. So giving you these two fields amounts to giving you the velocity. So yeah, velocity of the ions, you are given the field. So doing that, yeah, so 10 to the 5 divided by 0.55. We'll work out the numbers later. And the unit should be in meters per second. It could be a good exercise to kind of figure out how to go from volt per meter per Tesla to meter per second. I think electromagnetism units can be a little bit complicated, and kind of working through that yourself, it helps you cement their relative relationships to each other. So now, understanding magnetism in the Bain-Bridge spectrometer. Without knowing what a Bain-Bridge spectrometer is, I'm gonna just assume that the magnetic field is set up perpendicular to the velocity. So, the magnetic field produces magnetic force that's always gonna be perpendicular to velocity. So it ends up being centripetal force. So and it'll describe. It'll say. Build a circular path as the centripetal force, so it writes this down. The magnetic force, again, assuming the V and B start perpendicular, then V cross P just gives you V times B magnitude-wise. Say that force is the centripetal force, and then you solve it for M. Yeah, that's it. And then it says plug in the given values. So is it just giving me the answer? Let's just double check that is correct. And I don't know if it would have behaved a little bit differently if I gave it the prompt, my usual prompt, but I don't have a lot of time remaining, so let's just finish this up. The formula is a charge, and was it singly charged? Yeah, LiIL. So the charge would be elementary charge. Oh yeah, it already said that. Yeah. Elementary charge times the radius 2.39 centimeter times this applied magnetic field 0.75 Tesla. That's a pretty large magnetic field, divided by the V. Now for V there, I'm gonna do E over B, so it'll be 1E5 volts per meter divided by 0.55 Tesla. Yeah, let's see if this gives me something in the unit of mass. Yeah, 1.6 times 10 to the minus 26 kilogram. I'm a little worried that there's no, I wonder, it was probably 1.60, so, or, 1.58. Let me see what happens if I just put in 1.6. I think it's gonna tell me it's wrong, because yeah, it's just barely outside that 1% range. So how do I, let me try. It might be following the significant figure rules. Oh yeah, it's following significant figure rules. So you just have to specify more significant figures in the input numbers to force it to give me more sig figs, which I guess, I can say that it's trying, but I wish there was an option to just override it here. That would have given me, um, more option, less just, wasting time clicking around. All right, so let me see if there's a question that I would regret not doing. If there isn't, I might just call this end to the session. Yeah, I think magnetism intro is on the easier side once you get the right hand rule. That's probably the most significant difficult to think. No, although no. So I guess within this chapter, do I also do Biot-Savart's law? I must, because this you need a Biot-Savart's law. Now your textbook probably derived this for square loop, but let me ask ChatGPT. Let's see what it says. Is it gonna walk me through what's a fairly long derivation, or will it just give me a formula? I wonder what hint says. Yeah, there's a worked example. So, and in fact, sorry, I misread it. Sorry, I misread it. I thought you need to get magnetic field generated by a square loop of current, but no. It's not about asking for a torque. So it's actually pretty easy. In fact, let me check. How do I do this? So there's a way to do this that's super simple. There's a formula for magnetic torque. The formula for magnetic torque goes as torque is equal to magnetic dipole moment cross product with a B. Like if you do this, and M is for a current carrying loops, I times area, then like you can do it really quickly. You can also do it by, I guess, it's that formula. It's equivalent to what I'm writing down here. So yeah, if you're doing it that way, then yeah, they'll give you, probably 2.5. Now, don't do it this way. That do actually learn, read through it, and make sure that if you're asked the same question again in our required one-on-one meeting, that you can actually do it without referring to any notes. So yeah, that's the easy standard way. You can also do it the more painful way. You work out the force on each segment of the loop and calculate the torque from that. You can do that. It's just more work. Like, why do you you don't need to do more work? Yeah. So I think that's probably it. I don't think we do Biot-Savart's law. Like, this is actually an example of a problem where if you simply use this approach, you'll get it right. But if you do a force on each segment, I've tried it once and accidentally missed it. You have to really carefully work it out if you do it segment by segment. I remember this being a bit tricky. So, but if you're using just the magnetic moment cross product to the B, then the net force is gonna be 0. And the magnitude network is, let me see if I can just do it in my head using that nifty formula. So, current 10 ampere times the area. So it's gonna be 10 centimeter times, that's the hypotenuse of that being the opposite side of 60. It's gonna be square root of 3 divided by 2 times 8 centimeter. That's the area, base times height for the parallelogram, and times the magnetic field, 0.5 Tesla. That should give me something in the unit of torque and Newton meter. Yeah, is that right? Maybe. Seems a little small, but yeah. And if you try to do it, the thing that threw me off is I guess the point at which a force appears to act, like you shift from here center to here center, but that kind of gets offset by I think these doing something. Using the magnetic torque formula is a lot easier. But I do think it's instructive for people to go through segment by segment. I wonder if ChatGPT can help you do that. So let me just try this out and then I'll call this session to an end. So I got this answer using the magnetic torque formula, but the professor says that it'll be quote-unquote instructive to work out force on each segment. Can you help me do that? Into clear understanding, maybe. Yeah, so this is the force formula, and you do that top and bottom, current flows. Yeah, so the parallel in both segments. Wait, what? No, it did it wrong. I mean, I is to the left, so it's into. Yeah, it might not be able to help you because it does, I think, a struggle with these geometric things. Yeah, I don't know how useful it'll be, just because. Yeah, because it does struggle with the geometry things involving geometric reasoning. So as you read through this, you might realize, the right, left, and upward, they are not parallel, but ChatGPT can't do geometric reasoning. So anyways, I think that's good. That's enough. And next week we have Biot-Savart's law and Ampere's law. That'll be more fun. We'll do it then. Thank you so much for joining this virtual class session. And I will see you next week in lab.